A very good morning to all of you students. Today I am going to give you the short proof of the Liouville's theorem. So this theorem states that if an entire function is bounded for every z, then it is constant. So what is an entire function? We know that an entire function is a function which is analytic in the whole complex plane. For example, sine z, cos z and so on. So I am going to prove this theorem using Cauchy's inequality. So I will write from Cauchy's inequality, we have mod of f nth derivative at z, this is less than equal to m n factorial divided by r raised power n. So name it as equation number 1. So what I am going to do, I am going to put n is equal to 1 in this equation. So on putting n equal to 1 in this equation, or we can say in equation first, we get mod f dash of z. So first derivative is simply I am writing it as f dash z. So f dash z, this is less than equal to m into n. N is 1, so it is 1 factorial divided by r raised power 1. So this is again less than equal to, I am going to write as m divided by r. So as r goes to infinity, as r tends to infinity, so from this equation we see that from this inequality, when r goes to infinity here, so this term goes to 0. So 1 divided by infinity, or we can say that m divided by infinity, so that term goes to simply 0. So from here mod of f dash z, this goes to 0. So we can say that this function is constant for all finite values of z. So as r tends to infinity, f dash z, this is equal to 0. That is, f of z is constant for all finite values of z. So this is the shortest proof of this theorem. So we have to simply use the Cauchy's inequality theorem. So now I am going to give you one example which contradicts this theorem. So if I will take f of z, this is equal to sine z. So this sine z is not constant. As per Liouville's theorem, this is not constant because this is an unbounded function. So sine z is not bounded. So it is unbounded. So this is a contradiction to this theorem. So we can say that it is true for complex valued function. So it is true for complex valued functions. So sine z is basically unbounded. And we know the expansion of sine z, and expansion of sine z is z minus z cube by 3 factorial, then plus z5 by 5 factorial, then minus z7 by 7 factorial, plus so on. So if I have to take the mod of sine z, what I will do, I will take the mod on both sides. So this is the mod of z minus z cube by 3 factorial plus z5 by 5 factorial minus z7 by 7 factorial plus so on. So again we know that mod z, this is the circle with center at origin and radius r. So I will write here, this is equal to r minus r cube by 3 factorial plus r5 by 5 factorial minus r7 by 7 factorial and plus so on. So if it is bounded, if it is bounded, then what happens? Then mod of sine z, this should be less than some constant, but this will never happen. So this will never happen, as this will never happen. So we can say that this modulus value is never less than some constant term. So we get that this sine z, mod of sine z, this is unbounded. So if it is unbounded, so then it is not constant. So this example, we can say this example contradicts the Liouville's theorem. Thank you.